Hi everyone, we're just going to take a quick look at another differentiation problem here. This one's taken straight from a textbook. An open-topped aquarium, 15 centimeters high, is required to hold 600 centimeters cubed of water. If we designate the length by x and the width by y, number one, express y as a function of x, and number two, what dimensions must the aquarium have if the surface area of glass is to be a minimum. So this is a typical little volume versus surface area problem. And we're reminded that it's an open-topped aquarium, so we're only going to be looking at 5 surfaces of the potential aquarium. So what have we got? We've got in our aquarium a height of 15 centimeters. We can designate this other one by x and the other one by y. So the first thing we can do is get ourselves an expression for the volume. Now we're told that the volume is 600 centimeters cubed, but the volume itself, 600, must be equal to the 3 sides multiplied together, 15 times x times y. And you should be able to see that we can now very quickly obtain an expression for y as a function of x. All we do is rearrange this little equation to get the statement that y is equal to 600 divided by 15x. So now we have something which tells us what the value of y is. 600 divided by 15 times whatever x is. And we'll go on to find out what x is in a moment. So that's the first part done. We've expressed x as a function of y. Let's go on to the next part then. What dimensions must the aquarium have if the surface area of glass is to be a minimum? Okay, so this is a very often the type of question where we're trying to minimize one thing or another. So what is the surface area then? We can't make it a minimum till we can actually say what that surface area actually is. And just to make sure I'm getting these numbers right, you've got 2 surfaces which are 15 by x here, one on the front, one on the back. And if that 3D picture confuses you, one on the back, one on the front, whichever way it goes. So there are 2 of those. There are 2 surfaces which are 2 times 15x. Let's put a bracket around that so we can actually see what we're doing. We'll multiply that a little bit later on. So another surface we've actually got 2 of is y times 15 for the 2 sides of that particular thing. So we've got 2 of 15y also. We've only got 1 of xy because it's open top. So we've got 1 of xy. So it's an open topped thing. So if we multiply this bit out, we end up with a nice expression for our surface area. So our surface area is going to be 30x plus 30y plus x times y. So what we can do now is take our substitution, our value for y that we did up here, and we can substitute that in to our equation at the bottom. So it'll start to look a bit more complex, but there we go. Surface area now is equal to 30x plus 30 times y, which is 600 divided by 15x plus x times 600 divided by 15x. Okay, so that's our expression for the surface area now entirely in terms of an x value, which is good because we're only going to differentiate in terms of one variable. So let's just move that up and work some of these things out and see what numbers we get. So surface area, once again, 30x, nothing's changed there. This bit here is going to be 30 times 600 divided by 15, which is 1200 divided by x, which we can write as 1200 x to the minus 1. You can check that calculation yourself. And the other one is going to be x times 600 divided by 15, which is going to give you 40, because the x's are going to cancel out and 15 goes into 600 40 times. So now we've got an expression that we can use in our differentiation. There's an expression in x's for the surface area. All we need to do now is apply our knowledge of differentiation to come up with a response. Okay, so we're going to take the surface area and we're going to differentiate it with respect to x. So we're doing that. Let's just write it out. 30x plus 1200 x to the minus 1 plus 40 with respect to x. So we apply our differentiation rules, and what we get then is our dsa by dx is now equal to 30. Right, now here we have a negative, right? So we're going to bring the negative in front, okay, and then see what happens after that, and we get a total of, let me just make sure I get this right, negative 1200 x to the minus 2. Okay, and the 40, because it's a constant, has disappeared. So here we have an expression for the differential in our exercise here. Okay, and strange thing appearing on my screen. Let's just turn that off. Something to do with my touchpad. Now that we have that expression, we're going to make that equal to 0. So now 0 equals 30 minus 1200 x to the negative 2. Okay, because we're looking for the point where it's actually going to be a minimum. Okay, and it's going to be a minimum when the slope is a 0. Okay, and it's going to go to a minimum because the x term here has got a negative sign in front of it. Okay, so we're expecting a curve that looks somewhat like that. It might be a bit bent to one side, but not worry about that. So now we can rewrite this that 30 is equal to 1200x, and I'm going to write the x squared on the bottom specifically now. Same thing here. So we can actually see how this is going to track out. So now we know that x squared is equal to 1200 over 30 x squared, let's just keep going, is equal to 40. Therefore x is equal to, therefore sign, the square root of 40, and we'll come back to that in a minute. So we've now found one of the dimensions of our fish tank. We can then go back up to our expression up here where the y is equal to 600 over 15x. We can use that to find a value for our y. So y we know is equal to, let me just check that I've got that right, 600 over 15x. So it's 600 divided by 15 times root 40. Okay, so 600 divided by 15 is 40. 40 divided by root 40, I hope you'll agree, is itself equal to root 40. So in other words, if I can get up here to change my color, the y value and the x value are both equal to the square root of 40. In other words, we've got a square on the bottom of our fish tank. So root 40, that's rough. Sometimes maths teachers should do problems which actually appear in the real world. And here is the fish tank. It's 6.3 on a side, 15 centimeters tall. It holds 600 centimeters cubed, which is little more than an English pint. But I'm not quite sure what kind of fish you're going to put in that. So there's the problem solved, but it's not particularly a real world example. I hope you can follow that through, and I'll see you in the next video. Take care.